So like, it's a weird one. I think when you're learning this kind of language, like a Haskell inspired type of language, I suppose it's like you can see. I mean, it's very clear. Like I know when I first started looking at Haskell, like I read a lot of stuff, and it was like, you don't need to know category theory to like be productive in Haskell. Not that like it's easy to be productive in Haskell, but like as you dive deeper into it, there's a whole lot of weird words and concepts that are like underneath. Do you know what I mean? So you know that like the sort of like the practical level is pretty practical. Like I can map stuff and I can filter things, and it's like fine. It's like all good. But then occasionally you do hit the odd thing where you're like, why can't I map this thing? Do you know what I mean? Like I could previously map stuff, and now I can't map these things. And then it's like, and then you dive into it, and it suddenly everything is like defined in terms of semi-groups, semi-rings, rings, functors, monoids, monads, and then you're like, what is this stuff, right? And then it's like, okay, no, so fundamentally it's like built up on top of category theory. Well, I don't know if it's like built on top of category theory, but it's certainly defined in terms of category theory or something like that. So it's super useful. Like they definitely intersect, and I think like the more you learn Haskell, like the more you may be attracted to wanting to understand category theory, which I think is pretty cool. Like I think they're very intertwined. It doesn't seem like I don't really know category theory well. Like I've been through it, and I've been through some of the proofs, and like what is it, like the composition diagrams and all those rules. And it's like that's not that useful for me. I like want to work at a higher level where I just go, yeah, I can understand broadly what is a semi group, and I kind of know what operations. I almost see it as like a class of things, And then actually it works quite well because like Haskell's got this thing called type classes, and those things are often defined in terms of type classes. And actually I prefer the understanding of the programming side inspired by category theory rather than like being stuck in the category theory side and then being able to use it with a language like Haskell. If that kind of makes sense. I don't know. It's a tricky one, but it's cool to understand both sides. I definitely will. I think make you a better programmer in general, which I think it's like a good thing, right? It's always a good thing.
Yeah, I suppose so. Unless you want to change jobs, maybe. Um,
But I'd
yeah.
say in any job that you can think of today, don't you think programming would make you better at that job? Like think of a job where programming would not benefit you.
Mm,
Come on,
like
give you
I might.
5 seconds.
Okay, plumbing.
Plumbing,
Yeah.
to be a plumber.
Yes.
So when you're designing like the plumbing infrastructure for a house or whatever, you're not going to use like you don't think programming at some level like disrupts plumbing. I think it maybe does. I don't know. I mean, I don't want to be a plumber, to be honest, but
Apparently, the
I
money's
think
pretty.
you'd be a better plumber if you were a programmer and a plumber than just a plumber, right? I think you'd be a better plumber.
uh, I think we're off topic.
Yeah. All right, cool. How's it, everyone? I'm like very tired today. Like I did not sleep very well. But is my screen is shared? Hey, yes. Okay. So I went through the stuff that we did quickly this morning, and I just cleaned up some of the things. So just like maybe just a quick recap, and then like if you got have got questions, like let's dive into that. But I think the last time, which I think was more than a week ago actually. So I don't know. So we talked about like we had this function, right? Terence's function. List takes a list of int and it returns an int. And we said, well, what we want to do is like we want to filter out all the even numbers from that list, and then we want to sum them up, right? And we said, cool, that's very nice. But like, how can we maybe use some of the language features to? I mean, it's a very contrived example, but like, let's use some like overkill language features to maybe make this a bit more easy. To read or to refactor, considering the fact that every function that we write has to be a single expression. So we can't do stuff in the middle. Like if this was a more procedural type language, we could clean this up by using another kind of mechanism by saying, well, we could have like interim steps, right? So we could have said, like, var, whatever, like the evens, is this filtered thing, is that list, and then later on we want to return the sum of the evens, right? And we can't really do this like two-step kind of thing in this language, because it's not a single expression. This is no longer a single expression. This is there's a statement of two things going on here, right? And there's not really a mechanism in this form to do this. So it has to be a single expression. So that means like this kind of piece has to kind of go in there, if that makes sense, to make it a single expression. Do you know what I mean? So like reduce all your arguments into one, or reduce all of your steps into like that single expression. And of course that like is going to not be cool, right? It's going to suck when this becomes a bit more of a complex thing. So we looked at some of the mechanisms to deal with that, like the let syntax. So let syntax allows you to not create like independent statements, but it allows you to like factor out sub expressions. Right? So I can pull expressions and name them like I would expect in another language. Like I can give a name to what is this expression called is even. I can give a name to this expression, which is 10 is even. I can name this value x. I can name Drickus, the string Drickus, as x, and then I can write my expression with those things. So that's cool, right? So it's not breaking the single expression rule. It's just allowing you a way of like naming some of the stuff inside that expression. So when you wrap it up, it's like easier to read. So when we fundamentally look at this, like I think this is pretty reasonable actually. So it's Terence's Func Prime 3, the third version of it takes a list of int. And this was kind of just dummy stuff to just like demonstrate maybe some shadowing or whatever. And you could put other stuff in there. But it's like, okay, so it's a list of ints that is filtered by is even. What is even? Is even is this like anonymous function, I suppose, that takes the modulus of its parameter and tells you whether mod2 equals 0. So that would tell us that it's an even number, whatever, and then we sum them. So like that's kind of your way of like factoring and making your functions like read nice and cleaning them up a little bit. This is one such way. When we go into things like effects, there's another mechanism. Actually, we start to see it down here called do. So there's this thing called do, which actually kind of, in some sense, does kind of give you a way out, like a safety hatch into that more of that like statement world, where it's like this thing must happen before this happens, and if that thing fails, what must happen? Like the program must cease to run, right, or something like that, right? So it allows you, and really what it's trying to do is it's trying to create a very deterministic ordering of side effects. So do is often, I think maybe it's exclusively usable in, no, it's not always for only effect, but it's with whenever there's kind of like a monad in play. An effect is a type of monad, but we're not going to get into that for a little while. Like it's scary stuff. Let's just like deal with some language stuff. So is everyone comfortable with this? Oh yeah, so the opposite of let, or not the opposite, like an alternative. Here we have let in. So between the let and the in, you can put your little whatever you want, like values or variables or functions or whatever you like, and then your statements at the end, your expressions at the end, sorry. And then there's an alternative syntax called where you put your expression at the top and then where down beneath, and there you can factor them in, but they're completely equivalent. Everyone comfortable with that? Any questions around that stuff? I'm going to delete it all.
Yep,
no?
Comfortable. I quite like
Got
the
it.
where syntax. That's quite nice.
Yeah. And you can interestingly, so like this thing can go quite deep, where you could go, like say x equals Drickus, we don't like this, we want to go x equals my name, and then you could say where my name equals Drickus, right? I think we can do that. No, we can't. X equals my name where? Yeah, there we can actually. Oh yeah, so it's giving us an error about the shadowing. Let's just call this like x prime or something. So you can kind of do that. Oh yeah, it's probably because it it wants that like that. So like it kind of scales, right? So I can keep doing where and let and in, and like it'll just recursively resolve these things. You happy with that? So anytime you've got an expression, that expression could be a let in or a where expression. Any place you have an expression, you can like break it up like this. So here you can kind of see this is your like it's not bad actually. It's like once you start writing this, it can be like can be a little bit scary, but like it takes a bit of practice to get used to. But actually it works kind of just as well as like you might think that not being able to write statement one after the other is like a big disadvantage. It actually isn't really, because everything does kind of like you can reduce everything just with replacing variables. Really, it's kind of the same thing. You could take any statement, certainly statements which have no side effects, and you could refactor them as single expressions. I mean, I think I'm not sure if that's like mathematically, but certainly in my mind, like, yeah, absolutely you can. So you're happy with that, eh?
Yep, happy.
Yeah. Okay, cool. Any other questions? I'm going to delete all of it. Drickus, Daniel, Terrence?
I'm all good. I've been following this pod at least.
Okay, good. That's good, man.
I looked at the
yeah.
Sudoku one, and I have not
Did
been
you?
following that one.
It's bad. It's like the worst. It's terrible. It's like it's actually so awesome because the code is so awful that like I got it to work, and it kind of works, and it's like I'm embarrassed by how bad it is, and that's awesome. It's like like I'm such a novice actually. Oh yeah, one other thing that I remember I said to you there's something to do with this pipe. So I did quickly Google this thing, and this comment with a pipe just above a function will turn it into a doc comment. Why didn't I think you have to build it or something, and then I did get it. Yeah, there. So you can see like when I hover over it, it shows me my comment underneath. So that's pretty cool, right? So if you use that little pipey thing there, then when I hover over stuff, I'll get my description of my own functions, right? So I think that's pretty cool. Use those things. So I'm going to delete all this crap.
Sorry, just one thing before you delete it.
Sorry. Yeah.
Where you've got the where syntax versus the let, I can see that.
Yeah.
I'm assuming that all of that is scope there. So within that, whatever output you're returning from there, then the 10 is even will be discarded, and you cannot access it again. But what I'm thinking is that I can see where I would pipe maybe another function like another filter sort of onto that option. But in the way, I'm not so clear on like if I had to flip it around, do I underneath the sum, do I just add $, another filter if I need to add another expression that I've defined there?
Oh, under the where here?
Yeah.
Like there?
Yes.
Yeah, I could, absolutely. So I could say is odd, and then I could say, well, mod to not equal. Do we know how to do not equal? I don't know. Yeah, it's not that. Not equal? Yeah. What is not? Yeah.
Do you think it's the keyword not?
Binary not.
It could also be a tilde.
Common operators. Yeah, it could be. Yeah, these things. Yeah, syntactically. So, that's the binary not, but I want a not equals, right? Oh, yeah, good question. PureScript not. Because remember we looked earlier and we saw actually the equals is part of the eq class. Not x. I don't know. This is for you guys. Homework. I'm too stupid today. It could just be that we like not the whole thing, right? I don't know.
Yeah, that's what I was gonna say. Like
maybe we have
not
to
around
write
the whole thing.
Not or negate. Yeah. Hard. It's because if we click through on this, we know that the equals operator is an infix version of eq of the eq function, and it obviously look, there's a not eq. There we go, and there's the operator for not eq / equals. I mean, come on, guys, surely.
So intuitive.
I feel like that was designed for a what you call it. What are those fonts called? Like Fire Code?
Right. Oh yeah.
Become like an icon.
Miguel, you've reminded me of something. I put that here. Look here. Look at these little characters. So you can totally use the nutty Unicode versions of arrow and double colon. Those are totally valid. As
I don't know. That's a good thing.
yeah. I mean, I've actually seen a few code bases where people have used like Unicode characters as operators. Like I can't remember. There's a thing called insert math symbol. So I've got a. This is a Visual Studio extension called something Unicode LaTeX or whatever, right? And it can. Oh yeah, so it goes from the LaTeX. latex, spelt latex, characters with these backslash thingies, and it'll insert the Unicode version of that. So you can, I think you can even use like the lambda. So we could even define a lambda like that. Lambda e equals e plus 1, and this is f prime of what is wrong? Doesn't like that. Maybe it does need the backslash. Yeah. Okay. So I can't put the lambda symbol in there. Oh well. Well, then it's useless to me. Anyway, I wanted to just point that out. So, Migs, you can totally do this. You can make your code beautiful by putting in all these mathsy symbols. Doesn't show you its roots, right? Okay. So what I thought today is, and you guys can guide me, but I thought I'm going back to my list of things that could be interesting. It keeps growing on the bottom actually. But so we talked about this, everything's an expression, let type syntax, and it's quite a big one. And then what I had next is like how do records work? So how do we create like composite like objects, right? And maybe some pattern matching. And I start to run out of steam here, so it could be a lot of Googling. But effectively what we want to do is we want to build like and I need a good example, but like we like need a structure, right? So I want to say maybe like a use, I want to say, hey, I want to build a user or something, and that user has got a name which is a string or something like that. You know what I mean? And he has got an age which is an int. Do you know what I mean? Like that's what a record is, right? It's like an object in JavaScript, or an instance of a class in C# or whatever, like a holder of data, right? Or a struct, or a dict in Python. And so we can totally define these structures, and we can name them and stuff, like the types of them and all that kind of stuff. So what is my problem here actually? So it's not happy to parse this thing. So I think I can do this though. So I can say f is a function which takes a something and returns a let's just like return an int, and I think I can go like it takes a name which is an object which has a name, and I can say f of that, I'll just call it like obj equals, and maybe we return 5 always, right? Yeah. Okay. So you can, so I know it's like weird like this, but it's like actually we're saying f is a function that takes a record. This is record syntax. As soon as you see that curly happening, it's actually this I think is syntactic sugar for another form of this, which looks like this. And let's see if this helps maybe more. Record of name string to an int, I think would look like that. Let's just pull that up. So there's f with an obj returning 5, and f prime with an obj is returning 5. Yeah. So this, so maybe that's more confusing actually. I don't know. So effectively, I can create a type just by using these curly braces and putting inside it like what thingies it has. So maybe it has a name and it has an age, which is an int, right? Something like that. And then Does that kind of make sense? So it's like I can freely create a new type, which is it's like a record type with different things inside it for this function, like right here. I mean, this is like a bit weird because maybe you would want to name this type, like this is a person or something. But at its like lowest level, I can do it like right here. Do you know what I mean? You're comfortable with that?
Yep.
I think
On my side.
anyone's uncomfortable, then put up your hand. Like I do find this a little bit uncomfortable, to be honest. This reminds me a lot of like TypeScript, right? TypeScript kind of supports this because it's very JavaScripty, and so like being able to define new, not so much like JSON, but like JavaScript objects in line is very important in JavaScript, of course. And so TypeScript has this kind of thing that when you pass a structure, you can type it like right in line. So let's call this function. So we know that. So it's a bit weird that it always returns 5. That's a bit strange. Let's just have it return the age plus 10 or something, right? So I would just go obj dot age plus 10. So I've got dot syntax. So that obj there, remembering that obj is the first parameter, which is that object, right? So on that object, I can go dot age, and I can pull out that like field or whatever within the record. Yeah, totally happy with that, guys. Yeah.
Yep.
Yeah. Okay. Yeah, that like shouldn't be too surprising. There is another way. So is this a good time? No, not yet. So this is probably not how I should do it, but let's come back to it. So maybe what we want to do is like we want to make this like a type, right? We want to give this a name so that it can be used in other places. Oh yeah, we can make this primary one the same. Can we? No, it doesn't like it. It lacks a label age. Oh yeah, of course, because I never put age here. And so this would be comma and int. So I can create a record exactly the same way as that. I don't know if that's that useful. Maybe I should kill it. Hey, it's not that useful. This is more like how it's implemented actually. I think that's more useful. So type. I think I can go type. So I can say type person equals, and I can make this a thing called person. Yeah. Yay, good. The coolest way of formatting these things is like this, of course. Who hates that formatting style? Commas at the beginning of the line, lined up with the open bracket.
I think it's more they lined up with the open bracket that I'm not a fan of.
Yeah.
But
I don't know. Yeah.
I'm fine with.
Yeah. This is a very Elmy thing. So if anyone's written Elm before, Matt has written Elm. This is like you cannot avoid not writing structures like this.
It doesn't look that weird to me.
Yeah, over time it looks less and less weird. And when I first saw it, I thought, oh, it's so horrible. And it's like I forced Elm to like, no, you will be cool like this. You must do this, right? or whatever. Depending on whether you're a Java Sharp, that's the difference between Java and C Sharp, isn't it? Where that starting bracket lines up. I've always tended to be on this side because like my background is C and C++, and that was more the convention. Although, actually it depends. It depends a lot. But and JavaScript, this seems to be the convention. C Sharp seems to be the anomaly by putting it there. But anyway, Elm goes and says, no, guys, it must go there. And in fact, that comma is the thing. So it looks like that, and then your close bracket like doesn't have anywhere to go, so it must line up with the comma. Anyway, I dig this kind of difference, but this over time does grow on you. Actually, it's quite a cool way of defining them. Anyway, so now we can go. Oh, cool. This is going to be interesting. Now we take a person, right? Yeah, that works. Happy with that. So you can just kind of define types. Type person is this of this type, and now we can call it person everywhere, right? Yeah. I think that's cool. So we could even, maybe we want to create maybe we want to like modify the person's age, right? So we want to, let's go set age. Let's make a cool set age function. So it's going to take a person and it's going to, of course, we can't modify that person in place. So we must always return a new person. So let's see how we would do that. So now we're going to, let's call this person. Now we're going to kind of return a new person. Ooh, I wonder how we would do this actually. So here's the naive way of doing it. We would say name equals person.name, like we're copying it, right? We say age equals person.age plus. Oh yeah, so we want to, let's just call it not set age, but like increment age, right? We want to increment the oak's age by 10. Do I go colon maybe? Yeah. Yeah, there we go. So like, that would be your function for incrementing someone's age. So I think that this is feeling a bit painful, right? Because it's like, oh, I had to copy stuff, like I had to copy his name and all that stuff. There must be a way. I can't remember how to do this. Did I open records? Yes, I did. So I'm Googling, as I warned you I would. There is this interesting thing we must look at, which is extensible records, this colon, which is actually quite cool.
So just a quick question with the
there.
type person.
Yeah.
The type. Does PureScript or functional in general support, I'm assuming, duck typing, if that makes sense, where you specify, because you had earlier in your first example, the structure of the object or the record that you wanted, but now you've created a type. Would you be able to pass the type into a method that just defines the structure, and as long as that type has the properties that you want, it will accept it and be like, it's fine, I don't care what type you actually are, but you have what I need to work?
Yeah, it's such a good question. Yeah, my memory says yes. It should just be based on its shape. So like how it's shaped. It doesn't really matter so much that it's actually named a person, because this actually gets, like from a compile perspective, that word person gets substituted with that, if that makes sense. So as long as other types also look like this, they're actually the same type. But let's test that one. That could be very cool. So actually, if I just finish my modify one, Migs, and we'll get back to yours, it looks like I can do this. So I can say, well, it's actually the same as person, but where age is set to that. Does that make sense? So that's kind of the way to say, so, we've got Tom or whatever. Let's just do it here. Should I do a let? Oops. Yeah, and a in, and we can say like Tom equals, I think then I go person, I wonder. Name equals Tom, age equals, I'm going to be 39 still, guys. Is that cool? Yeah, I think I can do that. I think maybe this do needs to move, and I'm not going to explain why. Okay, person can't be there. It's not a constructor. We're going to deal with that as well. Oh yeah, no, I need the colon. Sorry, the equals is like when I'm, yeah. Okay, so there's a Tom, right? And then I go, on Tom's birthday, we want to increment the age of Tom, right? Sorry, we add one. Yeah, so let's call this birthday. The birthday function takes a person and increments their age, right? Yeah, happy with that. So it's like Tom is a record, he has a name and an age, and that's Tom. Like remember, Tom can't be changed. I can't go tom.age equals 50 or something later. Like that's not possible. Records are like immutable. Everything in this language is immutable. So Tom can never be anything other than what is defined here. But of course we can create a new Tom. So we can say, well, Tom, the next Tom is, we call birthday on him, and we get back a new Tom, and that new Tom he will be the same as Tom, name and age, but where the age is modified to whatever it was plus 1, right? So that's the syntax. It's like, oh, I take a person, I'm returning that same person, but and then this kind of record syntax again, but now with an equals in there versus a colon, because it's saying like modify, like copy but change, right? Happy with that?
That one's weird for me because it feels like you're changing the age that's in that person record, but you're not. Like you're creating a new age, but it feels like you're modifying the one that's in there.
Yeah, absolutely.
But like surely that's by design to make it feel
Yeah.
sort of closer to, I don't want to say normal, but what people are conventionally used to.
Yeah. And actually, like, it's not to say that there's no concept of modify. Like, modify is actually a thing. Like, you can talk about things like, oh, I'm going to take this string and I'm going to modify it. It's just underneath. It's not going to modify the original. It's going to give you back a new one. Like, but you can still talk about modifying things. Absolutely. Like, here you could say this Tom is a modified Tom. I wonder if I can't name them the same, unfortunately. If I could, that would be quite cool. And actually, I don't see why I shouldn't really be able to, because this one could shadow that one. But I think probably it's just like a bad idea overall. So like you could assume that next Tom is the modified version of Tom, right? You know what I mean? So it's just in the way you consider it. Like, I didn't modify the original Tom. I modified it, creating a new one, right? And so yeah, I think you're right, Ricker. So like from like a syntactic perspective, it's like it reads well. It's like, oh, okay, person, but with age set to age +1, right? And then I'm like referencing the original person. Maybe that's a bit weird.
Well, with the syntax change, if it was like a different property. So like if you use I can't remember what the 3 dots is called, object something.
Yeah, splat, the splat operator.
Yes. So if you do that,
or spread, I think it's called spread in JavaScript.
Spread, yeah.
Python calls it splat, right?
If you define like properties, if you use that spread and you like add on or you want to change it, the sort of syntax is the same. So you put the colon and then those properties. So you don't know whether that field exists on that record or not.
I've got you. Yes.
Does it look 100%? Different?
And I think that speaks to this thing, this colon here. So it's the extensibility of it. In fact, I think what this is saying to us is that, so if we look at this guy, it's saying type lang. I don't know what a lang is, but it's a type of lang that is kind of based on an L, where it adds a field called language, which is a string, on top of L. So L could be kind of anything. Could be anything. It could be a person. But lang is like an extensibility. It's an extension on top of L, and L could be anything. So it's kind of like, I suppose you could think of it as like a inheritance. So it's like lang has inherited from this thing and added this thing to it, but without even knowing about what it is. Doesn't care what it is. It doesn't care that it could have been a record of person or dog or cat or what it like. Doesn't care. Whereas inheritance, I think generally like you kind of need to. So that it's like the inverse of inheritance. Whereas, if that kind of makes sense. But let's play with it, Terence. Like I'm actually not too sure. Let's experiment with it and see what we can do with this thing. But I think that's the point. So let's start with Miguel's question first, which was it Miguel's question, where it was like, oh yes, if we pass something that looks like a person into this function, would it be okay just kind of if the kind of fields match, right? Because if we think about it, like a birthday doesn't always have to be a person, right? It could just be anything. Because if you look at what our implementation does, it only actually cares about the age field. It doesn't actually give a damn about name, right? So in fact, couldn't it just be a record that takes anything that has like an age in it, right? And returns, now this gets complicated. So it's like, okay, so, but then what would it give us back? Because this is kind of what you're saying. I know you use the word duck typing, and you're saying like birthday can be applied to anything which kind of has this signature or that prototype or that interface, right? And returns back that thing. Well, I don't know. Let's see what happens. I think it could be like, I don't know how we would write this up here. So now it's like birthday is a function that takes a record with age int, and it's going to return us a record with age int, and it's going to be like an anything, like whatever, and it's just going to increment the age of that whatever that you give it to us. So now it's weird because I can't call Tom, and it's saying type of expression contains additional label name. Yes, okay, so it's saying, hey, wait a minute, you can't just call birthday with Tom because it also contains the label name in it. is at least as general as type age of int while checking that expression blah blah blah. So I think we can potentially fix this by going like, I don't know, let's see. So it's like it takes an A. I don't know. How would we fix this, guys? Do we have to say a person? Like, do we have to fix it up here at the type level? Maybe we do. So maybe we have to go type. So an aged thing, something that has an age. I'm going to call it aged. Bad name. So now I'm just playing now, dudes. You're welcome to jump in with ideas here. And we're going to say, oh, person is person of, oh yeah, so an aged thing is anything which is a anything where there are anythings added. See how this syntax, the line up with column lining up actually does work quite well. So an aged thing is a thing which has an age and any other records in it, right? So a person, does he keep these ages? I don't know. I don't actually know. So now let's have this thing take an aged thing and this thing take an aged thing. Doesn't like that. Why not? Oh, aged of P, returning an aged of P, potentially, because it looks like we kind of want to parameterize this thing, A. So it's like, okay, let's call it A. Is undefined. Okay, so here's another funny thing for all A's. You can ignore this thing. I think we might have done it. Make sense? So let's try and unpack it, right? So what we're saying is, does it, see if someone else can explain this. Miguel, does this make sense to you or no?
You lost me at the for all.
Okay, ignore that.
I was following right up until the for all.
Ignore the for all. Pretend that doesn't exist. We'll come back to that. It's called a quantified type. And I actually don't understand it well. It's just like wherever you put type variables, you want to constrain them to particular types. And we're saying for all. So it's like it doesn't matter what type it is. It could be of anything. Like it could be a person, right? So ignore that. But explain does this make sense? So now, try and explain it.
So the way I'm following it is more from like how TypeScript does it. So the aged with the A is the equivalent of in a TypeScript definition where you put a square bracket where a property name would be, and you say this type is string to say, obviously, your property can only be of string types, which you need, well, it can be anything, but JavaScript's weird. And then you give it another like any type, and you're now saying, okay, you can add anything onto here as you want. And right, yes. That's where I'm following on that object. You're just specifying that object is now the type because it has an anything property. It doesn't care what the other stuff is as long as the main portion is still there, and you'll only be able to access the main stuff that's hard defined. I'm gonna just say like strongly defined in the property because you wouldn't know about those dynamic things. That makes sense.
Yeah. So that is your like duck typing, or it's more of an interface. I would call this like potentially more of an interface. So like birthday says, hey, I can modify anything which like looks like, has this kind of form, aged of A. And what is aged of A? So the A is a bit odd, but it's like, okay, it's like a record that's got a field age and anything else. And it's like, well, what is the anything else? It could be, because I suppose we could hard code this and resolve it in this way. We could say it's an aged person and type aged. I think I would kill that and I would say no, it's like joined onto a person or something. Could not, yeah, because it's looking for a type. Is it looking for a kind? Do I say aged of person? No, I don't know. It's like we're telling it what to extend, and it can kind of extend any type. So it's like of type T, it's like an extension of type T. So it's like any type which has got aged there. You know what I mean? Interestingly, it could also be like, has an age there, and then like maybe we also have a payload of type A. You know, like that little type parameter can be used inside the structure as something. It would be a bit weird. This is probably just broken for other reasons. Nasty errors. That's kind of how I think about it, but that's an interface. So this is saying there's an interface called aged, which just adds, you know, it's anything that's got this thing on it could also be considered an aged. And so when we write the birthday function, we can take anything which is an aged of that type. And we are happy to return it, which is interesting, right? So it will return back an aged, person, I assume. And look,
I think what might make it clearer for me is if we also update the type of person, because our person also has an age, but aged has an age. So I'm looking at your thingy on the left there, where it extends the other thing. In my mind, you would go type person equal aged, open bracket, name, : string. Is that right?
So we're taking it out of there. So like,
yeah. Do you not need to update the definition of the person type to make it work? Or is it just magic?
So interestingly, I think this thing is like Tom is not a person. You know, he's just like a record with his own random fields in it. And so he isn't aged. Yeah, so here's an interesting question is like, I don't know, name of, what would be a good idea? I don't know, let's just call it get name, right? And get name takes a person and returns a string. So get name of person, fine, equals person dot name, right? So there's a cool function to get a person's name. So can I get Tom's name equals get name of Tom? And I assume that I can't now because it's saying, yeah, but Tom here is not of type person. He's of type record with that stuff in it. Yeah. So it's like that contains an additional label called age. So he's clearly not a person. I suppose I could have said, I mean, actually the better way of doing it is to say, hey, type checker, Tom is a person. Sorry, that is a better way of doing it. Right? And now it's saying, okay, but a person doesn't have an age. Right? Because we took it out. And it's saying, well, now you can't call birthday on that because it doesn't have an age. So I do need age here.
I think as well from Matt's example in the side there, like then it can be there, that section where it says that can then be extended, like I think he's referring to that portion. We haven't done that on person, if that makes sense. The line just before the highlight.
Because the extension's the other way around. We've done it there.
So like, Tom, in the browser, that next line where it goes type language equals open bracket country, it's like extending lang that you defined and adding a property called country onto it. So I think we could do that with age, and then extend age
I got
person.
Oh, yes. Okay. Oh, I hear you. So I can say person is an aged, but with a. Now we have to go back to like round bracket syntax. We can no longer use our cool inline record syntax, right? Like that, right? Yeah. Yes. Okay, yes, I totally see what you're saying. Yeah.
Thanks,
and now we
Matt,
don't have to repeat. We don't have to repeat.
Cleared it up for me as well, because I was also scratching my head, but now that explanation helped me.
Yeah, 100%. Yeah, good point. Yeah. Okay. So like records, right? They feel a bit weird, but actually they're not too bad. This kind of extension stuff, I wouldn't get too hung up on it. I don't think you use it too much. I mean, maybe you do for like if you want to create like this prototype-y, kind of like Golang-ish actually, like duck typing, yeah. Which is cool, but like I don't think in general you're going to use that a ton, but yeah, 100%. So it's kind of like an inheritance, I suppose. You could imagine it's inherited, right? So person inherits from aged, but adding this name thing, I guess so. Of course, records just hold structures, right? They don't have functions attached to them, but of course you could include functions. So you could have a type on here, like it might be like a bit wacky, but like I could say like get age. I mean, I'm not suggesting you do this, but like get age is a function that given I don't know if I could repeat person here, gives me an int. I don't know if I can. Yeah, so it doesn't like the fact that I've got person inside the person. So like that is a bit strange, but like let's imagine it was like we had a function called, I don't know, ink age or something, or whatever, some random thing, f. You can embed inside the record a function, right? And so I could evaluate, I could call that function as well. So does that make sense? So I could, why is this giving us issues? Oh yes, of course, because we added name but not f. So f is now, an anonymous function taking an int and returns 5 or something, like weird, but you could. Happy with that? So records are just holders of things, of any things. Probably don't do that much. Don't do it much. Okay, so we're happy with this. I'm gonna. Okay, we'll keep it. No, I don't think we'll keep it. Let's just kill it. Let's go back to our simple example, which was where we had name, string, and age int. Cool. This thing always takes a person and gives us a person. It's not a person of A, it's just a person. Happiness, and now the for all can go, so Miguel can be happy again. Okay, the for all's gone, and we're good again, right? So one interesting thing here is when we call this function, so now I'm going to talk about pattern matching. So pattern matching it's probably the last thing we talk about this. It's like, I mean, for today, like it's a big topic, but one of the very cool things we can do in this language is we can pattern match stuff. So what does pattern match do? It's kind of the concept of matching and destructuring at the same time. So it's like a combination of like a switch statement, but along with a destructuring of that thing. So it doesn't matter if you don't know what either of those things mean, but here's how we may do it. So instead of right here where we say, hey, birthday takes a whatever, and that whatever is a person, sorry, is always a person, so we know that. We could actually destructure it right here. You guys comfortable with the concept of destructuring? So I could just say, actually, like I know it's a person, so just like whip out the name and the age fields right here. Comfortable with destructuring like that? This would be like, if you had trying to think of a good example. Try not to use Python now because Vincent said I can't pick on Python so much. So I will use
JavaScript. I was about to say that's quite a Python-y thing to do.
Yeah, it's a beautiful thing to do in Python, right? I'm going to use Python. Sorry, Vincent. So you can go like, I think you do use square brackets. You go like that equals. Oh, no. You go like A, comma B equals like if I want to destructure an array, right? Right. So this could be an array of 4 things, and it's like, oh, I want to pull out the first element as A and the second element as B. Is that how I do it, Drickus?
Yeah, that's correct.
Python, yeah.
So
I use
array or from a function or something like that.
Right.
If
it could be for
return.
anything. So in Python, this is called a tuple or tuple, right? The round brackets is a tuple, and the cool thing is a tuple can be like x equals a tuple of 1 and 2, right? So I can put it on the right side of this expression, I suppose. But the cool thing is I can put it on the left side as well. So I can say, actually, x and y equals 1, 2, right? And that's going to say, oh, look, the thing on the left, like things on the left generally are introducing new, or like naming new things or new values or whatever. And like here, there's only 1 on the left, 2 things on the right. So this is a tuple of 2 things, 1 and 2. And on this side, it's like, oh, look, x and y destructures the tuple on the right with the value 1 and 2, correct? Everyone comfortable with that, this kind of thing? You've seen this. I mean, quite a few languages are starting to do this. Python did this very early, which is very cool. Like the destructuring idea is like really awesome. I don't know if actually even in C# or Java you can do this yet, actually. Can you?
C#, very limited at the moment. I think they're adding more and more with C# 9, and JavaScript allows you to do this now.
Yeah, JavaScript ES6 allows the destructuring, yes. Right? Which is cool. So here it's the same. Like we're just destructuring up there. It just happens to be like a record being destructured. So we're putting it in the record kind of structure. Does that make sense? So now it's weird because like person no longer is a thing over here. So I would say, oh, okay, so age actually, return. I'm just going to write this kind of dumbly, but it's like, okay, so the name must be name and the age must be age plus 1, right? So kind of happy with that, right? That sort of makes sense. I'm just destructuring it right there. Yeah. So in this language, it's actually kind of pattern matched it. So it's destructured absolutely. So that's one part of pattern matching. Interestingly, I wonder if we can do it like right here. We could go, maybe with the record it's going to be confusing. Let's try something a little bit more fancy. Say we had a function f. It takes an int and it must return an int. So we've got f of x equals, x plus 1 or whatever, it increments that thing. We can put something in here called we can ask a question of x before this thing gets run. So here's maybe the most basic way of doing it, is we can say, okay, but there's also so if f gets called with 0, the answer to that is -1. If f gets called with x, the answer is x plus 1. What do you think?
Would that be the equivalent of like a circuit approach in like other imperial language, where you have like an if statement in this, like right in the beginning of like, yeah, this properties is just like return this. Don't even process whatever else I want to do.
Yeah, that's definitely one very cool use case for this kind of thing. But isn't it also kind of batty that I'm saying f of 5 equals 25, but f of x equals x? So I can keep writing like f's here. It's like, oh, wait a minute, how many f's have I got? F of 100 equals -50. Like, oh, look, I'm defining a new f and a new f and a new f and a new f, right? I thought we only had one f. F was an int to an int. What are all these other things?
I'm starting to lean towards overloads now, like within.
Yeah.
Like
you can think of it like that. You can think of it like that. Drickers, what were you saying?
No, so I wanted to say that the first thing that popped into my mind was like a recursive function where you have like your escape clause, so that if it's 0, then return like -1, then you end the recursiveness of it. That's just the first thing that I thought of when I saw that.
Yes. That's a very good thing to think, because this is how you should do that. So when you have a recursion, like it's called like your terminal step or whatever, you can define separately. I mean, a different way to write this mess here would be like f of x equals like if x equals 0, then -1. Else if x equals 5, then 25. Else if x equals 100, then -50. I'm just looking at these cases here, right? Else it's x plus 1, right? I mean, that's a different way of writing this, because it's like, oh, okay, yeah, my constraint, if I had the constraint that f can only be like written in one place, like implemented here once, I would have to write it like this, like a big if statement, or like a switch statement, or whatever mechanism I want to use to return these different values depending on what x is. The cool thing is I can just keep writing new functions like this. And what PureScript or Haskell are doing And a lot of other languages do this. This is pattern matching. So what it's going is it's saying, hey, this f. So if down here, if I call f 75, right, and I go result equals f of 75, I'm going to press save, and look, it all compiles. It's saying it doesn't like the type of this, and it's like, you do like the type of it. Case expression contains unreachable cases. I don't know. It's probably because of this. So I'm calling result f75. What the compiler is going to do, or when it evaluates this, sorry, not the compiler, is it literally is going to say, is that first parameter equal to 0? No, it's not. Is it equal to 5? No, it's not. Is it equal to 10, 100? No, it's not. Is it equal to x? Yes, it can always be. So this as a pattern matches. It goes, it's an x. Like, it's okay. And so it will resolve that one, x plus 1. Do you know what I mean? It doesn't mean that I can change the parameters, though. I can't say, like, f of x and y equals x plus y. It's like, no, that's broken because, I don't know why the error is up here. Argument lists lengths differ. It's not a new f. So these are not new f's being introduced. They're the same f. They've just pattern matched the first parameter there. Yeah. And if this thing did take two things, like takes an int and another int and returns the sum of those ints or whatever, it could be like this. We could say, we can use them interchangeably. And when it evaluates, it's because of this one. I'm going to kill that one. It's a bad example. F of 75 and 100 or something. The runtime is going to pattern match all these properties here. So you could even have weirder ones like f, it must be 0 and y must be 50. The answer to that is minus 500. Do you know what I mean? So it's going to pattern match the 0 against x and the 50 against y. This one, it's going to go, it's 100. Then whatever's next is like set it to the variable y, but it matches, right? So when it looks at that, it goes, yes, I can do that. X is equal and y can be made equal. So this is doing a comparison and this is doing a destructure. That's why when I said about pattern matching, it's the combination of two things. The one is a comparison and the other one is a destructure, and it does that simultaneously. Because does that make sense? Because y is being destructured. It could be being destructured. Sorry, it could be being destructured. At the moment, it's just being set. So it's like it's an int. But if that was a record, we could destructure it right there as well. How weird is this? Terrence, is this weird? It's 9 o'clock also.
No, I'm pretty comfortable with that. I think that makes sense. I mean, you're defining the function signature and whatever overloads. That's the way I would look at it.
Yeah. I think overloads is not a bad way to think of it. Yeah, I think initially that's not a bad way to think of it. Yeah, this you're going to see everywhere. Unfortunately, this appears in all places. This like testing and setting in Notion. Because it's not really overloading. It's not like f is overloading x. You know what I mean? It's not really an overload. Like overload would be, I'm calling a function with different type parameter, with different argument types as parameters, and so it's going to match the one that's appropriate. It's here. There's no type changing. Like it's always an int and an int. It's not really an overload. You know what I mean?
Okay. Yeah.
But I think at a higher level, it's the right way to think about it. Okay. Any last questions from anyone? Bhavesh, Drickus, Matt, Miguel, or are we done?
I have a quick one, and I might be opening a rabbit hole, but if we didn't care about the value of y in the f of 0 function, could we do an underscore there?
Yeah, exactly. So like match anything. But now the problem is it's like, oh, but you told me about y here. So it's like, oh, okay, yeah, because I don't care. I can underscore it and not name it. Yeah, but it will still pattern match it. Like it needs to be there. So it's still, so like the underscore is still kind of it's still an int. It's just an unnamed one, right? It's unusable on that side. But yeah, you're absolutely right. Yeah. Yeah, and we can underscore on that side also. So like I want to underscore. So like here's interesting. It's like, oh, match the 0 and then anything. Here it's like match anything and then a y. And like that's probably bizarre because like this is going to match like this one. Well, it's certainly going to be matched stronger than any of these. Like these are probably inaccessible now because of anything and anything. That's going to be like the most general matcher, right? That's probably what this error is. Yeah. So this error is telling us like, hey, this case expression contains unreachable cases. So you wrote these things, but like they're unreachable because this is everything. Check how cool that is. It's saying the X and Y one, the 0 and 51, the 100 and Y one. These ones are not reachable. That's brilliant, right? Compiler knows that. How cool is that? Whereas it wouldn't know that in your if then else thingy. I mean, maybe it could. No, potentially it could actually in the if then else one. Yeah. Yeah. Okay, dudes. I think we've got another session tomorrow morning. So tomorrow morning, I think we might get into something called ADTs, algebraic data types, which is taking, like, it's just, so here we've talked about a record structure. There's a higher level thing called an algebraic data type, which is actually very interesting. And it maybe builds on top of record. It just makes it's a more powerful structure on top of these things. Yeah. All right, dudes. Have a good day.
Awesome. Thanks, Tom.
Thanks, Tom. This was great.
Awesome. Cheers, dudes.
Cheers, guys.
Cheers, everyone. Thanks for the session.